The next section for the analysis is the predictive analysis. So this study also wanted to find out that could the variables, the demographics, have some association with somebody's healing status, somebody's trauma healing? Could it have been an issue? Could it affect it? Is it a big deal? Does your demographics affect that? So this is where we bring in the issue of logistic regression, because we have the dependent variable whether you have healed or you have not. So under the data for model, here you have we have the different variables in here. District of residence, we have different variables. We have somebody's residence, gender, age group, religion, all these variables. Then at the end of the day, we have the healing score in here. 0 means they have healed. 0 means they have not healed, and 1 means they have healed. So we want to look at the predictors of the healing status based on the people's social demographics data. So it would be good, since it is a binary outcome, healed or not healed, it was much better to run a logistic regression. Now there are 2 steps to run the logistic regression. We first have to run the bivariate analysis, the bivariate logistic regression, and then we can run the multivariate logistic regression. So those are the two we are going to analyze. But if you run the bivariate analysis, then there are some rules there are some conditions that must be met by the variable for you to consider it for the multivariate analysis. There are some rules that must be considered. But let's go through some of the basics. So first of all, in this analysis, the variables we are going to consider are just there are some variables we will not consider because they had so many categories. Like this question 2.8, what is your main source of income? These are so many categories which, if you try to run the logistic regression, the values cannot make sense. Sometimes you need to regroup so that you have fewer values. Also, this question Q211, what is your relationship with the person that has ever had trauma? This also had many subcategories and it wouldn't make sense. So some of those questions we are going to leave them behind. Also, entry level we're not going to consider because this was these are all baseline scores. Like before the study, that's when this data was collected, so it's not important to run. Intervention group we could add, we just maybe to know whether if you are receiving African wisdom only versus receiving combination versus receiving right mindfulness, could it also be a predictor to somebody's healing? Okay. Now we can consider that, but this second last, the healing score, we are not going to consider because it was used to calculate the dependent variable here, which is whether have you healed or you have not healed. Now, to perform logistic regression, you need to ensure that your data is encoded. Your data is numerical in nature. If it is string, then it can't run. Now, that is where the concept of coding comes in. Oh, if it's male, let it be 1. If it's female, let it be 2. If it's age group, let it 1 to 1, 2. But encoding manually like that, personally, I don't do that. It takes a lot of time and it makes it harder for you to interpret. So there is a faster way to code your data. We call it data encoding. There is automated encoding that you can use to encode this data automatically in SPSS. In Stata, if I show you a sample command in Stata, how it would look like. So this is how the Stata command would look like. You would do encoding 1 variable per time. So you convert this variable, district of residence, then you generate a new variable which will be numerical in nature, sort of. So you do encoding for all the variables. Then you drop the variables that are strings in nature. Now then this is your dependent variable. Then you can begin performing the logistic regression, binary logistic regression, where you have the dependent variable versus the independent variable. Then you get the odds ratio by adding I dot. That gives you the odds ratio. Then later, after running the bivariate logistic regression, you can then perform the multivariate logistic regression, where you put now multiple independent variables that have met some conditions all at the same time. Then you run the analysis to see whether the model will perform better, whether it will predict healing much better or not. So it's also the similar thing we would go through under SPSS, only that in SPSS it's a different step. So for SPSS, what we shall do, we are going to, let's import our data first. Let us import our data first. Come to File, come to Open, come to Data. So we're going to import the Excel data from this data set of ours, the Excel. We're going to import the worksheet called Model, because that is where the data for the model is. So this is our model data. Okay, let me close the previous data because we don't need. Now this is our model data. Now you can see that these are different variables that are available that we may need. We may not need all of them, of course, as we have seen. We need some. But what I need to pay attention is the data type. This data type is string in nature. But we need to convert these strings into another format so that it can be able to run a logistic regression. So the simplest thing to do is to come to transform if you want to automatically encode those data so that it can be numerical. Come to transform, come to automatic record, click on that. These are the different variables now you want to convert from strings. It detects that, oh, some of these are variable. What do you want to convert it? Because converting it into numericals. Okay, give it condition. So you need to take one variable per time. So here I say district of residence. I want to transform that because we need that one in our analysis. Then you need to specify the new name of the variable, the new name because after generating the numerical data, you want to it must generate a new name. So you want to generate a new name. So you say add new name. So here it will say after recording these, after doing the recording and the rest, it's going to convert it and it will create a new variable called residence. Residence is going to be the new name. So that is very okay. So here also male, female. So also take that. So that will be gender. So you give it name. The next one, this is marital status. So you can't put exactly the same name, otherwise it will bring an error. You can't put exactly the same previous name. Next, so you remember every variable you take the other side, it keeps on disappearing from the left-hand side so that you don't get confused. So next is age category. So I can call that an age group. Now, if you want to put a space, you need to put an underscore. If you say you're going to put a space, then it doesn't accept. Space is regarded as a character. It is illegal. So when you want to put a space in between that, put an underscore. If you put again this in the middle, it doesn't allow. That's also illegal. Because this can be interpreted as minor, so it doesn't take that. So you need to put underscore like down there. So next is religion. That one can remain as religion. So what we're doing encoding, where we change strings into a numerical data, but it cannot change it from the original variable you have. You need to generate a new variable. So that's why we are putting these new names. So these are like the new names for the new variables we shall be generating. So that is why we are trying to generate all these. So you need to do this one by one, and then you generate. Household income I don't want. Did you know anybody in the past 12 months who had trauma? Yes. I need question. Let me confirm the other questions I need. I just want us to use the same variables we used in starter. So we had after are you the head of household? Yes. Education level? Yes. Then we have this part, the financial status, such like financial status in the past 12 months. So we need that. So we are going to, so this is this variable. How did you, yeah, this is in the past 12 months, so that is financial. So I can call it financial status. Add that. Next is the household income. What's the men's household income? That we don't need because there are so many categories. Do you know anybody with the trauma? Okay, so we can add that. So that is variable. Question 210. So let's confirm that whether that is what we need. Question 210. 210. Yes. So we need that. We need that. So know someone. Let me just put here that know someone. Next here, question 211. What is your relationship with that person? We don't need that because it's what I said. It had so many categories. It wouldn't make sense to include it. Maybe if this could be recategorized into like fewer categories. Then question 212. Do we really need that? 212. Yeah, have you been performing any activity? Have you been trying to make a living? Have you been like active working? Are you like being engaged, like something like that? So that's why we have that. Where is it? Yeah, have you been like any activity? Like, has that person been active in some way? So we need that there. Which other variable do we need? Next is entry level and the intervention type. Entry level, we literally wouldn't really need that because entry level is baseline, endline, everything is baseline, so we don't really need that. I leave entry level. Intervention we may need because we want to maybe see the type of intervention. Could it be a predictor? Then I say, oh, okay, so this is it's exactly the same name. So let me add your type. All right. It was warning. So those are the ones. Then you need to choose. Use the same recording scheme for all variables. And then treat blank string values as user missing. You have to click that, choose yes, treat the blank string values as missing. So in case there is a blank space within that data, let it be missing. Yes, treat it as missing values. I tap on it. That is it. So that is everything you have in there. Okay, you can press OK, and then it will perform for you all the different encodings. Now you can see the difference in here that after you performing that specific encoding, it has assigned some values to your data. It has assigned some different values to your data, but maybe you don't like, because this is assigned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe you don't want that. Maybe you want, like, let's say males to be 1, female to be 2, and then if it comes to religion, Anglican, let's say, to be 1, Catholics 2, Muslims 3. Maybe you wanted to again go back 1 to 3, 1 to 3, 1 to 3, 1 to 3. Therefore, we need to click off the previous option that we had chosen. So if I go back to transform, automatically record. If you want to use that format 1 to 3, 1 to 3, then you have to click off this one here. If you click off this, you can be able to what? To be able to generate. But because we have originally generated the variables, so now it says that okay, it has already generated the previous variables. You can't change anything from there. So meaning either again you discard off whatever you have done, or you sort of again modify the name, modify that name of like what we already have. So I think maybe I could just modify that name. So again, I have to go one by one here. Residence, so I say now residence 1. So now because that is in case you want to generate your codes, which is like 1, 2, 3, 1, 2, 3, 1, 2, 3. But in this previous one, we had generated 1, 2, 3, 4, 5, 6. It didn't, like, it kept on moving forward, like it didn't repeat. So it depends on the use case scenario. But in this case, most people do really prefer that they have 1, 2, 3, 1, 2, 3, or 1, 2, 1, 2, depending on how many different categories they have. So I've added 1, 1, 1, 1, 1 at the end of all my variable name. So I've clicked this off, then I press OK. So it should be able now to generate the variables that has residence 1, 2, 3, 4, gender 1, 2. Depending on how many categories are there, it will always go back to 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, depending on how many groups are there. All right. Now that you've seen that, now we have now to perform our. Now let's go back to the data and we see. So we can see that now in the data has been generated more and more and more and more. Now, if you look at the new variables I generated in here, from where we began from residence, see now it's numeric in nature. If I begin from where I had my residence 1, gender 1, it's also numeric in nature, etc. And what's interesting is that if you look at under values, you will be able to see some interesting things. So under values in here, when you click here, you see it has all those subcategories it gave. So when I go down to my variables 1, 2, 3, 4, if you see it, lowest, highest is that. If I come into education level, for example, then you click here, you see. Now this is the coding that you see most people putting on YouTube, that 1 is equal to, then they open quotes, then they begin label defining and the rest. It's a very tedious process for you to go each and every time. 1 is equal to female, 2 is equal to male, yet you can automatically encode all these values so that you straight away have your values like automatically like coded. So that is how easy that I always go about that. So having transformed the data, let's now perform our logistic regression analysis. So to perform that logistic regression analysis, go to analyze, okay? Go to analyze, go to regression, come to binary logistic regression, click on that. Now once we are here, it will ask you to specify what is your dependent variable, the dependent variable. So your dependent variable is healing. Where is healing? Healing status. That is, if you go back to Excel, we need this last column, which is 0101. That is the healing status. If it's not 0101, it won't run. It must be 01, not 12, 01. So logistic regression models understands that 0 is the outcome not of interest, then 1 is the outcome of interest. In this case, we want to analyze and see the predictors of healing. Healing in this data set is being denoted by 1. So if you don't put your data here to be 1, it won't be able to recognize that outcome. It will bring an error. So that's our dependent variable. Now the independent variables will be put under these areas of covariance. That's where we want to put it. So in the first phase, we want to do districts of residence, for example, districts of residence. So I go under residence. Remember the last one we generated, residence 1, that's the one I want. I take it that other side. Next, here there are other options. You have to maybe specify some data, try to give information about it, and which other statistics do you want to report. On top here, you have what's called the categorical. It asks you, is this data you have chosen, is it categorical in nature? Is it categorical in nature? So you can choose that. Yes, it is categorical in nature. So, and we know residence is categorical because it's divided into different. Remember, you can also run the logistic regression using continuous data, but this is categorized. So I say yes, I take it the other side. Now, what is the reference category? Which reference category would you want to make the reference? The reference group. So, like in this case, if you go in this write-up, you can see that this is the reference group 1.00, and these other ones are being compared with that reference group. So, in Starter, the reference group is chosen based on the ascending order, the numerical, the alphabetical order. It's ascending order. So you always consider the first one to appear under the ascending order to be the one to be considered as the reference group. So in this case, if you want that to be the reference group, then we choose the option of the first. We want the first to be the reference group, like the first in terms of the alphabetical arrangement. Then you click change. So it will say, okay, reference group indicator first. So it will be the first. Then you press continue. Let's save under save option. What other things do you want to save from there? Probabilities, predicted values, and the rest. No, we don't really, nothing much important. We need that, but we may need logit. We need logit that is the odds ratio, we need that logit. That odds ratio is going to be very, very important. Do you need to include the covariance matrix? We really don't need that. It's not a very big deal. If you're doing logistic regression, it's always not an important statistics to report, so I can put that one off. These predicted values would create for you new variables, because remember, it's developing a model, so it will generate for you some new variables, and you don't want to be generating new variables anywhere. I click continue. Under option, what other thing do you want to report? Classification plots, case-wise, iteration history, CI, the confidence interval for the exponential B. I click that yes. The exponential B is more like the odds ratio. So the odds ratio is, at first you get the regression values. That's what you get, the regression coefficients. But for logistic regression, you want to report odds ratio. So odds ratio is always the exponential of that regression value. So you always get the exponential. So you need to also report the confidence interval for those odds ratio. So that's what you also click. Include the constant in a model. It's always not a very big deal. You can leave it, but you don't always report. But you can always leave that. You can always include it in the model. It's fine. Bootstrap, there's really nothing you really need to add there, so you need to leave it open-ended. Then you can press OK. So after that, it has performed for you the analysis. So up here it begins case processing. It shows you the variables, the original value, then the internal value. Nothing important from there. It shows you the frequency distribution in here. Okay, and how it was encoded, 1, 2, 3, how it was encoded within when we did the automatic encoding. Next in here, it's here showing you the two-way distribution of the dependent variable. Okay, versus the two-way distribution. It's to two-way, more like how this one also did the two-way for the different independent variables. Also performs the two-way for the independent variable, and then naturally the distribution is that's not a very important stat to report. Variables in the equation, this is the model itself, how it is generally performing, the scores, the constant value. This is the constant value, something like that. It's not a very big issue. Here is variables not in the equation. So these are the different residence 1, residence 2, residence 3. These are different scores, degree of freedom, and then the significance is also indicated in here. As you keep going down, there are so many stats it keeps on reporting as you keep on going down. The most important statistics I want you to focus on is the last one, the variables in the equation. The variables in the equation is what I want you to focus on. That's what I want you to focus on. That's the variable in the equation. Okay, so what do we have in here? So we have the different variables here, and then we have the significant value here. We have the exponential, that is the odds ratio here, and then the confidence interval, we also have it here. Those are the main stats we really need. And if you compare with the output we have, the finding we have in here. Okay, let's compare the interpretation. So we have on the right hand side under the exponential, this is the odds ratio we need, first of all. So when you're presenting, the first section is a two-way distribution, the frequency distribution between the independent versus the dependent. So it's not always so you always perform it the two-way table earlier. It's not really, this is literally really not part of a logistic regression, but we just add it to add some more description to the relationship we are trying to show. But from here is what we begin reporting. This is now the part for the logistic regression in here, the odds ratio. So here we can see that the different odds ratio have been indicated, and because we performed only one variable per time, that is what we call the odds ratio you get is called the crude odds ratio. The crude odds ratio is what you get at that stage. So we can see the crude odds ratio. Sometimes the odds ratio are like 0.000, doesn't really, like, it's just constant. So it always happens in case the independent variables are not distributed in the dependent variable. Like, it cannot really predict anything. It gives 0.00, or it gives a very weird score like this, a 999999411. It's a very weird score. It doesn't make sense. So in Stata, it's recorded as 1.00, or it's even written as omitted. Like, omit, can't perform this analysis. Omitted, we can't have anything. But when in a report, we just put 1.00, 1.00, 1.00. But the one which is able, like, to run, like this last one, 3.077, those are people who are from this district. This, you said, they were 3.077 times more likely to heal compared to their counterparts who are from this reference group, that is this compiler. And the reference group in here, it tells you that it's residence 1. So residence 1 is the reference group. So you can always ask yourself, what's residence 1? Residence 1, and whether it's interpreted somewhere earlier. All right, residence 1, by default, residence 1 is compiler. So you just know that, oh, residence 1 is this one. Let's try the household size. Household size. So to perform the logistic regression using the household size, I come to analyze, come to regression, bivariate logistic, take back what was there. Yeah, healing status remains here as our dependent variable. So I need household size, and it's here. This is what we need. We want to calculate that. I take it here. Then I come to categorical, say, oh, this is categorical in nature. Make the indicator, let the first be that, the indicator. Then I click on continue. Then we click on OK. When I come down and look at my values in here, I can see that the odds ratio are also agreeing. Okay, 0.850 is the odds ratio for this last category. Then this is 0.000. As I said, 0.000 just recorded as 1.00. That one, in most cases, you have the distribution 0 somewhere, like the distribution of the participants between the dependent variable is not, there is somewhere which is 0. If this was like 1, then we would be able to see some value. But since it is 0, it cannot. In Stata, this will be written as omitted. But in SPSS, it tries to calculate something. But now you see, even under confidence interval, it doesn't give you any value at all. It doesn't give you any value from there. Let us try for the financial status. Financial status, come to analyze, click on regression, do bivariate logistic regression, look for financial status, which is here, take it here, categorical, yes, it's categorical in nature, change this to be the first, click on change, OK, and press OK. Then it will analyze for you that. We can see the odds ratio is 1.149 here, 1.149, that is for this second category, compared to the reference group. So people with the very lowest financial status are 1.14 times more likely to get healed compared to the people who have an average financial status. So that is the finding in there. But for bivariate, it's not always a very accurate prediction. It's always, that's why we always report crude odds ratio. So we want to do multivariate. So multivariate, those are the variables that had p-values less than 0.25. Those variables, if you have p-values less than 0.25 at bivariate logistic regression, you can qualify to be considered for multivariate logistic regression. Now, the odds ratio we always get from there is called the adjusted odds ratio, and it is the one that we report as AOR. If you read articles, you'll always find AOR for adjusted odds ratio. So in this particular work, we want to do, we found out that district of residence, gender, religion, is that person active, like the person who is traumatized, are they involved in an activity, then a type of the intervention. They really qualified for multivariate logistic regression. So let's run it in SPSS and then you compare the values to see whether it would match. So now here I need multiple variables: district of residence, gender, religion. So let's do that. So for the analysis, so I come under analyze, regression, logistic, binary logistic. Let me remove what was there. So I want where do we have? We have residence first. We have religion. Remind me, what do we have? We have residence, gender, religion, residence, gender, religion, residence. I have here residence 1, gender, religion. We have activity, then intervention. Activity is here, then intervention type is here. Those are the things we have. Go to categorical. All of these, so select all of them, transfer this other side. All of these are all categorical in nature. And I want the reference group to be chosen based on ascending order. So click on reference category first, then you click on change. It will change all of these. Click on continue, click on OK. It will perform that multivariate logistic regression, and then you will be able to find your output in here. My most important is down here, the different odds ratio. This is the exponential B at the odds ratio I need. This confidence interval also I need, and then this p-value also I need. So these are the last 3 things that I do report in the write-up. So here we can try to see some comparison to see whether does our output agree with the what we found when we use Stata. And the district of residence, we can see that Wakiso had 1.7. We are looking into this column for the adjusted odds ratio. That is the column we are looking at, adjusted odds ratio. So Wakiso here, this is the last residence here, this last one. Odds ratio is the adjusted odds ratio 1.750, which is 1.750. That is it. That's what we have. So these other ones, this is too high and this is too low. Some of these distributions, as long as you don't see confidence interval, it means that those are like faulty values you can't report. So it's just easier to report them as 1.00, 1.00. That is much more, it makes much more sense. If we try gender in here, so gender, we can look at it is this 4th value, gender. So gender also is 2.289. You can see 2.289 is here for the male, meaning the reference is the female. So that is our adjusted odds ratio. So as you get along, that is what you find at religion, etc, etc, etc. That is what you find throughout even the last one in here, the intervention group. So the last one, the last category, intervention, 1.033. This is 1.032. Well, it's a rounding off error, but by that 1.03, 1.03, you can see that it agrees perfectly, very well. And so that's how you'd perform the multivariate logistic regression compared with also the bivariate logistic regression to be able to accomplish this particular task. Then in front, after reporting that, you also report the confidence interval, 95% confidence interval. So we only report for the multivariate now because that is the most important thing. So here we're only reporting for the multivariate. So that's the confidence interval we report here. The p-value, this column sig, those are the p-values. Those are the ones we report on the right-hand side here, the last one. And you're basically done with all the analysis. So this is just a write-up for that part, and that is it. So the interpretation are things like okay, people who had right mindfulness-based intervention were 1.032 times more likely to heal compared to their counterparts who had African wisdom-based intervention. Religion, here. People who are Catholic were 1.092 times more likely to heal compared to their counterparts who are Anglican. Right. Islam. People are 0.3 0.289 times. Okay, people who are Muslims were 0.289 times less likely to heal compared to their counterparts who were Anglicans. That's how you'd be interpreting your verse.